So this comes from section 4-3 in your book, Piecewise Functions. What is the crucial point to carefully graph on a piecewise function? There's a certain area on the graph that you definitely have to pay attention to because that's where we change from piece to piece. Here's our first function. You can see there are two lines in the function, right? It looks a little different than other functions we've seen, which means there are two pieces. If there are 3 lines, there are 3 pieces. We could go all day. There could be 6 pieces. We're only going to do 2 today. Okay, so we're going to learn to graph these. First, take a look at the different pieces. What type of a function is negative x plus 4? You know what your options are to answer? Quadratic and linear. I heard one back there. Connor? Linear. How do we know it's linear?
Because it's not being squared.
It's x to the first power. What about the bottom one? Also linear. So we know these are 2 different lines. Well, they have restricted domains. The top linear function is only when x is greater than or equal to -1, versus the bottom linear function is for all x is less than -1. So we have 2 different distinct pieces. And this -1 is where we change from piece to piece. So when we're setting up the graph, we have to make sure on our table of values, we figure out what the y is when we plug in x equals -1. Both of them, we have to plug in -1. That's the crucial piece. Now, if I'm doing the top function, maybe I'll call this y1. This is for all x's greater than or equal to -1. So I've written -1. What's greater than -1? 0, 1, 2. That's probably good. Okay, can you find the y values by plugging into the top function? This only applies to the top function. I see some confused looks. So the top function is negative x plus 4. So I take my x, I plug in -1. But I have a -1. What's our little saying for that? Little. Positive 1 plus 4 is 5. Can you do the rest? Plug in 0. Plug in 1. Because it's linear, you should see a pattern. We're evaluating at the x's that were greater than and equal to -1. Okay, can you do it all the way? What? Because 1 plus 4 was 5. When we plug in -1, we get a -1 in green there. -1. Do you have it on your paper? -1 is a positive 1 plus 4 is 5. All right, fingers in the air. When we plug in 0, fingers in the air, what's our y value? 4. When we plug in 1, what's the y value? 3. Now, how come I don't have to do work for the last one, but I should know what it is? There's a pattern. It's linear, so they have a constant slope. 5, 4, 3, 2. Okay, and then we'll continue, right? Now we're going to do a second chart for the second piece. Again, starting on that crucial point. Where's the crucial x coordinate? -1. So we actually plug in -1 on both of them. And then we continue with whatever the restricted domain was. This is from x's less than -1. Topeka, can you give me some x's in order less than -1? Yep. Keep going. Give me a couple more. Good. So this time when we plug in these, we have a new function. -3 times x minus 1. So the first x we're going to plug in is that crucial number -1. When you simplify, make sure you do it in the right order. Please excuse my dear Aunt Sally. Do we multiply or subtract first? You need to multiply. -3 times -1 is +3 minus 1, which is 2. Can you go fill the rest of the chart in? Plugging in to the x position, -2, and then do it again for -3, and one more time for -4. Come on.
It's not equal to -1. So which would we include -1? Even though it's not equal to -1?
Yes, because we're going to have an open circle and a closed circle. And this one has an open. Okay, plug in -2, see what you get. Okay, Derek, what'd you get when you plugged in -2? Does anyone second? 5? Yeah, because I would see +6 right here when we times -1. And at this point, you should already see the pattern. It went up by 3, and this is linear, so it should have a constant pattern. Add 3 and we get 8. Add 3 and we get 11. Okay, let's learn how to graph this. Now, we're going to be graphing both pieces. So if you look at the x's, we have positives and negative x's, and the y's, they go all the way up to 11. We don't have any negative y's, though. So for my x's, I need to make sure I go out to -4. Make sure you label and put arrows. And on my y, I need to make sure I make it all the way up to 11. Bless you. Okay, now, Connor just asked a great question. He said, this is actually x is less than -1. It's not equal to, right? So, I've used -1 twice, but it's true that only one of them is equal to it. So, if you remember back in 7th grade when you were graphing one-dimensionally on a number line with inequalities, there was a difference between an open circle and a closed circle. So this one at the top is greater than or equal to. Do you remember if that's open or closed? I've heard both. Uh-oh. Extra line means extra fill. So that's closed. So on this one, it's going to have the closed circle at -1. Versus this one, no line, no fill. So that will have an open. So if you want to write those down for yourself, we have the extra line, we have extra fill. No line, it kind of looks like cat whiskers, no fill. So when we first start graphing these, this -1, we have 2 points at -1. But one of them has to be open and one has to be closed, otherwise it's not a function. Because a function can only have 1 point for every vertical line. So at -1, 5, make sure you do a very obvious, nice, and large filled-in circle at -1, 5. The others are just points. 0, 4, 1, 3, and we already decided this was linear, so it should look like a line. 2, 2, and that's as far as we went. And then connect them. But we had it was all x's greater than, so we have a starting point, and then it goes to the right forever, because it's a line. That's the first piece. The second piece is all x is less than. So again, starting at negative 1, we have a point negative 1 comma 2, but should I do an open point or a closed point? Not for this one. Negative 1 comma 2 is open because it was just less than. Negative 1 comma 2, make sure it's very obvious that's open. You can't have two filled-in points right there, otherwise vertical line test fails and it's no longer a function. And then negative 2 comma 5, negative 3 comma 8, and then up to 11. And then you can connect them and it should be a line. So there are two pieces. And the transition point is at that x equaling negative 1. That's a piecewise function when you have multiple pieces. Questions? Yeah? Yeah, that's the graph. Yep. We're just doing the graphs today. Okay, we're going to practice one more, and then I'm going to give you 2 graphs to try on your own. Okay. So, example 2. Come on. There we go. f of x equals negative x squared, but only for when x's are less than or equal to 0. Then it changes to a different type of function, 1/2 x plus 2 when x is greater than 0. Okay? So I'd like you to turn to your neighbor and answer 3 things. 1, how many pieces there are, and then 2 and 3, which kind of is obvious, gives away number 1. Tell them what type of functions they are. 1, turn to your neighbor, tell them how many pieces are there. How many pieces are there? And then name what types they are. Linear and quadratic are the only 2 we've done. So it's either linear or quadratic. Okay, next, turn to your neighbor and tell them where the crucial point on the graph is. And is it y equals this number or is it x equals this number? Okay, everyone turn around forward, please. I think I heard only right answers. When we do our table, both tables have to have what number on them? 0, because that's where the pieces change. Okay, that's where the graph changes. So for the first one, y1, make sure you use a 0 for x. So for our top function, Gilberto, was this quadratic or linear? Great, because of the x squared is quadratic. This is for all x's less than or equal to 0. Okay, Andres, can you give me some x's that are less than or equal to 0? Give me a few more. Yep. And one more. Good. Ouch. For a quadratic, we know it's curved, so we definitely want a lot of points for the quadratic so we can see the curve. Okay, so we're just going to go through and plug them in. Make sure you use parentheses. That negative is on the outside, and then it will be squared. Negative 0 squared. Sadie, what is negative 0 squared? What? 0. Okay, then we have negative, a negative 1 squared. Brandon, what do you think about that one? A negative 1 squared. So we square first, right? You do the squaring first. Negative 1 squared is positive 1, but there was a negative sign on the outside, so it makes it negative 1. That's a little tricky. Okay, will you go fill in the last 3? First you have to square it, and then the sign changes. Yeah. Is there what?
There's a negative sign outside of that.
When the function is negative x squared, yes.
Oh.
Okay, good. Well, no. You have to square. Negative 2 squared is 4, and then make it a negative.
Right?
Yep. Okay, Jennifer, what do we get when we plug in negative 2? Good, because you square first. Negative 2 squared is positive 4, but then there's this negative sign in front, so it makes a negative 4. Good. Gabe, what about negative 3? Uh-huh. And negative 4, Kyler? Good. Well, it kind of looks like that. That's quadratic. Okay, that's the first half of the graph. Now we have a second piece. The second piece has to have a 0 as well. Both of them have to have that crucial point. Okay, but this one is for all x's greater than 0. So let's hear some x's greater than 0. Dominique, can you give me a list? Okay, that's great. But who likes fractions?
I do.
Oh, those guys don't like fractions. I don't. This one involves a fraction. Guys, I would like... You can have time on your homework, because we're almost done. You have 2 problems to graph yourself, and then it's your homework time. So let's get to it. This is a fraction. If we plug in 1, we still have a fraction. Notice the denominator is dividing by 2. So if you like fractions, go for it. Do all those numbers. If you don't like fractions, I would do numbers that are divisible by what number? Good job. 2. So maybe 2, 4, and 6. Okay. So for the work, 1/2 times 0 plus 2. Multiply first, then add, because that's how Please Excuse My Dear Aunt Sally goes. 2. Let me do another one. 1/2 times, I'm going to put this 2 up high because it's actually in the numerator. If we have a 2 on top and a 2 on bottom, it cancels out to 1 plus 2, which is 3. And then this is linear, isn't it? So it just follows 2, 3, 4, 5, and if you wanted, you keep going to 6. Okay, so we're going to graph this, showing the 2 different pieces. We have to be careful. One of them has an open circle, one of them has a closed circle. So can you show me in the air, please? This is open, this is closed. On the top quadratic function, at x equaling 0, should we give it an open or a closed? It is a, good, closed. Ow. So I'm going to make a note, remind myself that that one is closed. What about this one? There's no line, so no fill. Open. So when we graph the zeros, you have to be careful. If you look at the x's, we have both negative x's and positive x's. And the y's, we have negative and positive. So it looks like we need all 4 quadrants this time. And maybe the y, we need to go all the way down to negative 16, so I might bring that up a little bit. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's my negative 16. Y, what's our positive y? A 5? Oops, yeah. Okay, so the first table should look curved. It should be like a quadratic. Starting with 0, 0, we already determined it should have that closed circle. So make sure it's obvious that it's a closed circle. So I would make it big and make it very apparent that it's filled in. Then we have -1, -1. -2, -4, and it should start looking like it's curved. -3, -9. You start noticing it drops further, faster. -4, -16. And that's for all x's less than or equal to 0. So we have an endpoint on the right and an arrow going down to the left. Questions on graphing that piece? Okay, then there's a second piece. This table here is linear. Remember, we have an open circle, though, when x is 0. Let's do that one. So at 0, 2, maybe I shouldn't use black. We'll try blue. Make it very obvious that it's open. I don't like the blacks underneath it. Delete. Delete. And then put in your points. 2, 3, 4, I didn't go up high enough. And 6, 5. And that should look linear. This is for all x's greater than 0. So we have an open starting point, and then it goes on to the right forever for all numbers greater than 0. That's the graph. Okay. Any questions? I'm going to give you 2 problems to do in class, so get a new piece of paper, because you keep your notes until the day of the test. A new piece of paper, and once you're done with them, then you can work on your homework, which is just to finish your worksheets and watch the video.